Okay, I'm going to talk about question 59 in chapter 4. A minute of output is given below. There are some question marks in here, and in the question they are going to ask to find us these question marks. So this minute of output is about a hypothesis test and confidence interval for two proportions. Test for, two proportions, we have two populations, and then we get samples from them. Okay, sample 1 and sample 2, we get two samples from two populations. And then what's the sample P? It is x over n, so that's how you would compute that. And for sample 2, this value, p value, sample p value is x over n again, but 301 over question mark is equal to this. So we can easily find the question mark because of that. Okay, here n is the size of the sample 1, which is 300, and for sample 2 it's a question mark, which can be found by just dividing 301 by this. Okay, and then the difference is P1 minus P2. We will estimate the difference, and this is a question mark. 95% confidence interval is given, and the test, hypothesis test, is given. It's a two-sided one. P1 minus P2 is equal to 0 versus P1 minus P2 is not equal to 0. And then since this test with two proportions, the z statistic, the test statistic we use is the z statistic, and it's a question mark here. We can calculate that, and p value is given to be 0.680. In the first question, fill in the missing values. Yeah, the first question mark can be filled out as 301 divided by 0602, which we get 500. So this tells us the sample 2, there are 500 samples, members in sample 2. Okay, you can consider them as data. Estimate the difference. The difference is just P1 minus P2. P1 is what? 185 over 300 minus 301 over 500. So this is going to be the estimation of the difference. And then for the z-test, we need to find p hat. P hat is given as the formula x1 plus x2 over n1 plus n2. Here x1 is the number of defective parts. So this x usually shows a number of non-conforming units out of this many. For example, in sample 1, we had 185 non-conforming units out of 300 units. And in sample 2, we have 301 non-conforming units out of 500. You should read it that way. So p hat is x1 plus x2 over n1 plus n2. We get is 0.6075. And then z value is given by using this formula, p1 hat estimation minus p2 hat estimation over p square root of p hat in parentheses 1 minus p hat, which we just found here, times 1 over n1 plus 1 over n2. This is the formulation for the test statistic. So we know all of these. We know p hat, which we found. We know the estimation of these two is given here. Okay, so the result is 0.411. This is the z value, and we can write it in here too. So we found this, we found the estimation for the difference, and we found the size of the sample 2. Okay, and then is this a one-sided or two-sided test? Of course it's a two-sided test, because we have the difference is equal to 0 versus not equal to 0. And in part C, what's the p-value? If the alternative hypothesis is H1, P1 is equal to P2 versus H0, P1 greater than P2. Actually, this should be the other way around. So H1 is P1 equals to P2 versus H1, P1 is greater than P2. There's a typo here. So whenever we have two-sided tests, whenever we have one-sided test, it's gonna be the p-value is gonna be the half of the two-sided test. So we just take the half of that p-value. P-value, we can get the p-value from the Minitab output. Minitab output here. Okay. And then construct an approximate 90% confidence interval for the difference in the two proportions. It is very standard, so we have P1 minus P2 is less than or equal to the estimation plus the alpha over 2 because it's two-sided, right? So we have square root of, we have this sigma here. And sigma for two proportions is given as follows. And similarly sigma here. Okay, this one we can calculate because we know the values. The alpha over 2, alpha is 10%, 0.001. Take the half of it, 0.005. We can find it from the table. P1 head minus P2 head, we found it at the very beginning. So this is going to tell us that the difference is going to lie, the confidence interval is going to be from negative 0.0439 to 0.0732. And this is the end of the question.